Okay. So now we're going to answer the exercise 1.30 under section 1.8 components of vectors under chapter 1, which is units, physical quantities, and vectors. So we're going to answer letter B. So we already answered letter A in our previous video. For letter B, okay, so we have these following components. Okay, it's AX and AY. So both are positive. If you're going to graph this one, we have here an Cartesian coordinate system. This is our X, this is our Y. So our AX is positive, so meaning, okay, our A component is positive and our AY is also positive. Okay, so meaning our AY is around that direction. So meaning our vector A is in that direction in the first quadrant. So we can find this angle theta from the positive x-axis by using this formula. Okay, tangent of this theta is just equal to the opposite, which is the AY, opposite over the adjacent, which is the AX. So here implies that the theta is equal to the tangent to the negative 1 times this AY, which is 1.0 meter over 2.0 meter. Okay? Okay? Shift tangent 1 over 2. So our theta here is 26.6 degrees. Okay, 26.6 degrees. So our theta from the positive x-axis is 26.6 degrees. So how about letter C? Can we answer letter C? So this is for letter B, and let's answer letter C. For letter C, so our vector is located from the negative x. So this is our x, y. So we have here an ax is negative, and we have a positive ay. Okay, this ay is positive. So meaning our vector is in quadrant 2. Okay, this is our vector A. It makes an angle theta from the positive x-axis. So to answer this one, so what are you going to do first? Okay, first is that let's calculate this angle here. So let's put this as angle beta. Okay, and the tangent of that angle beta is equal to the opposite, which is the ay over ax. Okay, which is implies that the beta here is equal to ay, or tangent to the negative 1, ay over ax. It will give us uh, tangent to the negative 1, which is our ay is 1.0 meter, and we have negative 2.0 meter. That's case. Okay. Shift tangent, okay, 1 over negative 2. Okay, so it will give us negative 26.6 degrees. So what does it mean? So it means that from this negative x-axis, so moving clockwise, that's why negative, the angle that from here to there is 26.6 degrees. So meaning beta is 26.6 degrees. We get the theta. Theta is just equal um, to, so from x to positive x to negative x is 180 degrees minus this beta, which is, so meaning beta is 26.6 degrees. The negatives just tells you about the direction of the rotation. So here we have 180 degrees minus 26.6 degrees. So our beta here for letter C is 180 minus 26.6 is 153.4 degrees. Okay. Now let's go to now let's go to letter D. Okay, let's answer letter D. For letter D, let's draw this for letter D. We have an x, y coordinate. For letter B, we have negative x, okay, negative x, and we have negative y. Okay, ay and this is ax. So both are negative. So meaning our vector is in quadrant 3. So if that is the case, you can get this, uh, let's try to, we can get this angle here or angle here. So maybe let's try to uh, get this angle here. Okay. So let's label this angle beta. Okay. Tangent of beta is equal to the opposite, which is AY, okay, over the adjacent AX. So meaning our beta is equal to the tangent inverse of our AY, which is a negative 1.0 meter. Then we have negative 2.0. So it gives us tangent, okay, negative 1, negative 1 over negative 2. It gives us 26.6 degrees. Okay, 26.6 degrees. And we can find that the theta is just equal to, so this theta is just equal to 180 plus this beta, 180 degrees plus this beta. Okay, 180 degrees plus beta. So we have 180. So we have 206 degrees. 206.6 degrees. So those are our answers. So if you're given components, you can get the angles of these vectors basing on the components. Okay. So if you want some more of this tutorial, or what we call this one, solution manual, so please click and subscribe to our channel and leave a comment for more videos like this.